In this video, the learner will apply the segment addition postulate to solve problems. Remind yourself about betweenness of points. A point is between two other points if all three are collinear and the measures of the parts is equal to the sum. That actually leads us to the formal segment addition postulate. If A, B, and C are collinear, then B is between A and C if and only if AB plus BC equals AC. So our segment addition postulate will be our reason that we provide in proofs. So we're going to take a look at some proofs next. We're going to prove that if segment CE is congruent to FE and ED is congruent to EG, then CD is congruent to FG. We're going to use this picture to help us do that. We're given that CE is congruent to FE and ED is congruent to EG. So before we do anything, I want to mark our given information on our diagram. These little tick marks indicate that those pieces are congruent. In a proof, we always start with our given information. So my first statement is given that CE is congruent to FE and segment ED is congruent to segment EG. Our reason is given. Now, because I want to eventually prove that this whole segment CD is congruent to this whole segment FG, I'm going to have to relate the parts somehow. In order to do that, I'm going to have to use the measures. So I'm going to use this congruency statement and then say something about the measures. When we're looking at congruency, we only say objects are congruent, but measures are equal. So I have to use the definition of congruence to give me the equality instead of the congruence. Now that I have the measures, I can then use my segment addition postulate with the measures in that equation to help us further the proof. I know the piece CE is congruent to the piece ED. The measure of that segment plus the measure of that segment is equal to the whole measure of CD by the segment addition postulate. Now, because I knew that CE was equal to FE, that measure was equal, and the measure of ED is equal to EG, I can actually substitute those measures in for the ones we had previously. So instead of CE, I can have FE. Instead of ED, I can have the measure of EG by substitution. I also know by the segment addition postulate that these pieces, FE and EG, is equal to the whole measure FG. Well, now I have two things that are equivalent to the same thing. Both CD and FG are equivalent to FE plus EG. So I know the measure of CD is equal to the measure of FG by substitution. Because I know the measures of those segments are equal, I therefore know the segments themselves are congruent by the definition of congruence. In this next proof, I want you to analyze the proof information that you're given and fill in the missing question marks. Some of them are reasons and some of them are the statements. You're given that JL is congruent to KM. So this segment is congruent to this segment. You're going to prove that JK, this piece, is congruent to LM, this piece. So follow that proof and fill in those missing pieces. You're going to do the same thing here. Given that LK is congruent to NM and KJ is congruent to MJ, prove that LJ is congruent to NJ. So fill in the missing statements and reasons in this proof. We can also use the segment addition postulate in problem solving. So here we have a problem involving some measures of segments. it says PL is represented by the expression x plus 30. Given that point Q is between points P and L, where PQ is 11 and the measure of QL is 2x plus 29, what is the measure of QL? Well, first let's draw a diagram so we can make some sense of where things go. So we know that Q is between P and L. So we're going to draw that segment and then label the pieces. We have our pieces here that the measure of PQ is 11, the measure of QL is represented by 2x plus 29, and the entire segment PL is represented by the expression x plus 30. This can help us make some sense of what pieces we need to add together using the segment addition postulate. We know the parts have to equal the sum, so I know PQ plus QL equals PL. So 11 plus 2x plus 29 is going to equal x plus 30. From here, I just have to solve the equation. So add your like terms on the left, subtract x and subtract 40, and get x equals negative 10. Now notice it did not ask us for the value of x. It asked for the measure of segment QL. Now that we have the value of x, we have to use that to get that measure. So we're going to use the negative 10 that we found for x and substitute that into the measure of QL. So QL is equal to 2 times negative 10 plus 29, which gives us positive 9. So the measure of QL is 9. I want you to find the value of the variable in the measure of yz if y is between x and z in each of these problems. You're going to be using that segment addition postulate, so it would help to draw these pictures each time and then solve for the variable and the value of yz.